Hello everyone, I am B. Pavan. I am from ECE second year B section and my roll number is 20955A0411 and my AAT Talk topic for control systems is procedure for converting block diagram into signal flow graph. The procedure for converting block diagram into signal flow graph. Follow the steps for converting a block diagram into its equivalent signal flow graph. Represent all the signals variables, summing points and takeoff points of block diagram as nodes in signal flow graph. Represent the blocks of block diagram as branches in signal flow graph. Represent the transfer functions inside the blocks of block diagram as gains of the branches in signal flow graph. Connect the nodes as per the block diagram. If there is connection between two nodes but there is no block in between, it means if there is a connection present between the two nodes but in the absence of block in between them, then represent it the gain of the branch as 1. For an example, consider between two summing points, that is between summing point and takeoff point, between input and summing point, between takeoff point and output. Let us convert the following block diagram into its equivalent signal flow graph. Equivalent signal flow example. See the figure shown that the block diagram which we should convert it into signal flow graph. See here the summers there is two summers present at the input and then there is a gain G1 and G2 with the feedback H1 and then summer and so on, like gains and summer etc. block diagrams. Represent the input signal R of S and output signal C of S of block diagram as input node R of S and output node C of S of signal flow graph. Just for reference, the remaining nodes Y1 to Y9 are labeled in the block diagram. There are 9 nodes other than input and output nodes. That is 4 nodes for 4 summing points, 4 nodes for 4 takeoff points, and 1 node the variable between the blocks G1 and G2. Here the following figure shows the conversion form of block diagram into signal flow graph. That is which we have seen previously, the block diagram is converted into signal flow graph in the next slide. See here we can see the signal flow graph which is in conversion of the block diagram from block diagram to signal flow graph. Here see the gains are represented and the blocks are represented as the nodes and the gains are represented as just with a variable G1, G2, etc. Here input is R of S and output is Y of S and the feedbacks are denoted by the letter variable H. Here G is referred as a gain and Y1, Y2, Y3, etc. are the nodes, that is blocks of the block diagram. With the help of Mason gains formula, you can calculate the transfer function of this signal flow graph. That is, as we know that the block diagram is converted into signal flow graph. In the previous slide it was shown clearly, and to calculate and to find the transfer function of the signal flow graph we use Mason's gain formula. This is the advantage of signal flow graphs. So the main advantage of the signal flow graphs is you can calculate the transfer function by using Mason gain formula easily. As in the block diagram it becomes difficult to find the transfer function as we compared to the signal flow graph. So the block diagram is converted into signal flow graph mainly due to this reason. As the signal flow graph overcomes the defect of difficulty in finding the transfer function, we mostly use signal flow graph compared to block diagrams. Here we no need to simplify the signal flow graphs for calculating the transfer function. As in the block diagram we have to reduce the each and every blocks to find the transfer function. As we all know that all the block diagrams and reduced and combined to form a single block, by that we can find the transfer function of that block. But in the case of signal flow graph there is no need of the simplicity as reducing the blocks. So in this we can directly find the transfer function by using the Mason's gain formula. So the complexity and the difficulty in finding the transfer function as compared to block diagram makes easier in signal flow graph. So a signal flow graph shows the efficiency for finding the transfer function. So we use mostly the signal flow graphs, and it is easier to understand the signal flow graph as compared to the block diagram. Thank you.